Okay, chemistry module 3 review answers. Let's start here. If a substance can be decomposed, is it an element or a compound? Your worksheet might have a typo on that. And it is a compound. If it can be decomposed, it's a compound. Okay, next one. If a substance can conduct electricity when dissolved in water, that thing has to be ionic. That's when we did the lab, the thing that made bubbles. So that's going to be like your salt. Remember, ionic means something that's a metal and a non-metal. Okay, how state the law of definite proportions in your own words. Obviously, these are my words, so hopefully yours is similar, but it's always made up the same proportions of its elements. We're looking for the same proportion idea. Okay, a chemist does 2 experiments. One, he finds 14 grams of nitrogen combined with 16 and it makes 30. And then he calls that compound A. And then another, he does 48 of oxygen, 42 of nitrogen, and he makes 90 and he calls it compound B. Is it the same compound? He says they're totally different. But in reality, what we're looking for here, I'm not sure what's happening. There we go. 14 divided by 30. So I just chose nitrogen. Nitrogen compared to the compound is the same as the 42 of nitrogen compared to the compound. They're the same ratio, the same proportion. And then of oxygen, it's 16 and 30 or 48 and 90. And again, it's the same proportion. Number 5, substance is brittle and does not conduct electricity. That's going to be a non-metal. Metals are malleable. That's why you can take a ring and bend it into a shape because it's not too brittle and it can definitely conduct electricity. Number 6, which theory of matter do scientists believe today? Let's see here. It's a discontinuous theory of matter, not the continuous theory. Number 7, all scientists today believe that atoms do in fact exist. Has their existence been proven? No, it hasn't. It's like inferred and indirect, but they haven't been proven. Let's get into some math. Chemists decomposes 100 grams of some substance into 12 of carbon, 40 of magnesium, and then the other product was oxygen, but the gas escaped. So we want to know how much there is. So we are generally just going to subtract. So we have the 100, it's going to be the 12 plus the 40 plus the something. And you just need to subtract those out. So it's going to be the 101, subtract the 12.1, subtract the 40, and you get 48 grams of oxygen has escaped. That one's just your basic matter can't be created or destroyed. It just changes forms. And that one, it just changed form into a release gas. Okay, number 9, an experiment to determine how to make sulfur trioxide. A chemist combines 32 grams of sulfur with 50 of oxygen. So I'd start right there with like writing that equation. We have the 32 plus the 50, and they made 80 grams. And so what that was and here's the sulfur trioxide. And then they had 2 grams of oxygen left over. That's what's represented right there. So the ratio that we're looking for is you need to get rid of that extra oxygen. That's where the 48 comes from. We subtracted it so that you'd have 32 plus your 48, and that gives you your 80 with no leftovers. So then I put those into a proportion of 48. This is your oxygen over your 80. Total substance is going to equal to your X. This is what you're going to need of oxygen to your 100. There we go. This is I fixed, so they got rid of the extra. And then here's what we have. We've got our 100 over 80. So that's the scaled up, right? We started with 80. Now we need 100, and that's 1.25 more. So each proportion needs to be scaled up by 1.25. So we can just multiply it. Here's your 48 times your 1.25, your oxygen. So now we need 60 grams of oxygen. The other way you can do this is to make your proportions and then set it up. So here's our 48 of our oxygen over our 80 of our total. And that's going to be equal of our new proportion of oxygen over our substance total of 100. And that's what gives us the same thing. Or you can put it into your sulfur, which is the 32, which is this 32 up here, over 80, which is your total, which is going to be equal to your new sulfur divided by your 100, which is your new substance total. So that's your proportion basics. Okay, number 10. To make 44 grams of carbon dioxide, you must combine 12 grams of carbon with 32 grams of oxygen. So if a chemist combines 120 grams of carbon and 160 grams of oxygen, how many grams of carbon dioxide will be made? And then the second part is if a substance is left over, indicate whether it is carbon or oxygen and determine how many grams. Okay, so I want to start with the basic that they gave us is your 12 grams plus your 32 grams gives us your 40. Okay, I'm just going to write that out. And then we're going to find our proportion. 12 to 44 is going to be equal to 120 over what? And this is for our carbon. And doing that ratio, you're going to get 440, and that's grams of carbon dioxide. Actually, when I do undo, it's going to go away. The other way to find this, so that's one way to set up your proportions. I personally like it that way because I can always remember it. The other, the bummer with this proportion is X is on the bottom, and some of you have a hard time of knowing how to get the X out. So how to do that? First, we'll go over the oxygen part, and then we'll talk about it. So the other is oxygen. So they started with 32 over your total of 44, and that's going to be equal to your new amount, which is 160 over your new end result. And this end result said you'd be getting 220 of carbon dioxide. Now, here's the problem is the carbon gives you 440, but the oxygen only gives you 220. You can't get both, and you have to go with whichever is lesser because you don't have enough carbon, you don't have enough oxygen to fulfill all of those carbon needs. So we need to go with the 220 as our option. So we're going with the limiting, the thing that's limiting it here is our amount of oxygen. All right, so from that, we're going to go with our 120 of our carbon plus our 160 of our oxygen, and it can only make 220 grams of the carbon dioxide because that's what we found over here with our limiting of our oxygen. We have lots of carbon. We have plenty of carbon, which tells us that that is indeed our extra because look at it, told us it could make 440 with what we had. So then we have our extra as carbon, and we have 220 as our end result. And we're going to subtract the 160 of our oxygen. And that tells us that we only need 60 of our carbon, which gives us, oops, sorry, I went down the correct spot. Oops, which means it gives us 60 left. So we need 60, and we end up with 60 grams of carbon, our extra. Okay. Okay, number 11. So that's going to go away, but we need to just move on. Here we go. How we do 11? You're told that a molecule contains 17 atoms. If the formula is C5H10ClX, what could the X be? We just add those up, and it tells you 5 plus 10 is 15 plus something equals 17, and X equals 2. All right, number 12. Which of the following would be considered non-metals? Okay, on this one, all you need to do is check each of those with the periodic table. And you have your stair stepper here on your chart, and you find out, is it a metal or is it a non-metal? The metals being everything over here. We've got red, orange, yellow, and green are all different types of metals. So we just check each of these off. Now I got my thing in the way, so I can't find it. Shoot. There we go. Oh dear, it's still in the way. I don't know why it does that. It like blocks where I'm trying to move my mouse. There it is. Goodness. Okay. So for this one, which ones are considered nonmetals? We've got neon, the Xe, the xenon, and the S4 sulfur. Those would be your nonmetals. So you can find them over here. Here's your neon right here, your xenon. Your neon's right here, and here's your sulfur. They're on the nonmetal side. Okay, which of the following compounds would conduct electricity when dissolved in water? For this one, you're seeing, is it ionic or is it covalent? Are each of the elements nonmetals, or are they a combination of metal and nonmetal? So you go through each one. Carbon, hydrogen, chlorine, and fluorine. So we've got carbon, hydrogen really belongs over here. Then you've got your chlorine and your fluorine. So that one would have to be a covalent. So it would not conduct electricity. Sodium, nitrogen, and oxygen. Let's go look. Sodium, we're already over here in the metals. Nitrogen, and what was the other one? Oxygen, I think. Yes, so that one would be ionic. So this one should show up. That one's going to dissolve CS2. Here's your C, here's your S. Both nonmetals, it's not going to conduct. And your last one is BaSO4. All right, Ba is right here in orange. That's a metal. Here's your S, and here's your O. That thing is going to be ionic, and it will indeed conduct an electricity. Okay. Okay, naming compounds. This is historically a challenging spot for students. And the first thing I recommend is identify if it's ionic or covalent, because it has two different ways that we're naming them, which was on the worksheet that you did in the video last time. So step one, ionic or covalent. So let's check out this first one. It has Al2S3. Now, if it is an I, because some people are like, is that a capital S and then a capital I and then a capital A, capital I, capital S. If it's an I, it will have the top lines and the bottom lines to make it look like your classic I. It won't just be a line there. So let's look aluminum and sulfur. Let's see where they are on the chart. We have aluminum here in green and sulfur here in blue. So we are looking at an metal, non-metal. So this thing is ionic. And the rule with ionic naming is you pretty much just give them their name and add an "ide" at the end. Aluminum sulfide. Done deal. Okay, now we're looking at SF2, a sulfur, and 2 fluorine. So let's see if it's ionic or covalent. Sulfur, fluorine. Okay, this is covalent. And the rule with covalent is we add the prefix, except if there is one of something in the very first one. So here's our S, our sulfur, but we don't give it a prefix because there's just one of them. And then here's our F for fluorine, but there's 2 of them, so we say difluoride. Okay. C, we've got C and F6. Oh my goodness, you guys, these are like all doubled up. I'm going to fix that. Sorry if you're looking at BB and CC and DD. C and F, let's take a look. Here's our C. C is carbon. Here's our F. F is fluorine. These are both nonmetals, which means we are dealing with covalent. Okay, if we're dealing with covalent, we do a prefix. Now, the last one didn't have a prefix because it would have been mono and it was the first, so we don't say it. But for carbon, we do need to say it, and that would be di for 2, carbon. And now our fluorine is F6, and 6 is going to be your hexafluoride. So that's how we name that one. All right, last one, Be and F2. So you know, there's 3 fluorides here. So hopefully you're like, I know exactly where fluorine is on the chart. I know that it's a nonmetal. So let's just check out Be. Here's our F for fluorine. Here's our Be. Be is a metal. This says it's an alkaline earth metal. You don't need to know So this would be ionic. Now we need to name it in an ionic way, which means we don't need to do a prefix and we just add the "ide" at the end for a beryllium fluoride. All right, last question, number 15. What is the chemical formula of sulfur trioxide? All right, let's go look up sulfur. So we'd have to find the words, and they are little, but we've done something similar. So that sulfur is our S right there. And trioxide is going to be your oxygen. But because it says tri, we know that there has to be 3 of them. So that would be your SO3. All right, I hope this was helpful. Again, if you have questions, please